Hi, in this video, we are going to discuss 20 questions which are from the chapter Periodic Table and also Chemical Bonding. Let's start with the first question. Choose the most significant intermolecular force that presents between HCl molecule. So once we want to check the intermolecular force, the first thing that we're going to check supposedly is type of compound. Okay, so once we know HCl is covalent compound, so then you can start to ask yourself about the type of intermolecular force that may found in covalent compound, which there are possible hydrogen bond or dipole-dipole or London dispersion force. So when we look at the structure HCl, we know that the H is not bonded to FON. So hydrogen bond is not possible presence. Once we look at the bond between H and Cl, the electronegativity between these two atoms are different. So means that the dipole-dipole forces are present. So the answer is dipole-dipole force. Question number 2. Which of the following is a non-polar molecule? So there are two types of molecule will be considered as non-polar molecule. First, if the electronegativity between two atoms are similar. Second is if the compound is symmetry. So when we look at this question, all these compounds actually are symmetry, which is linear, but then we have to check the electronegativity. So among these, only hydrogen consists two atoms which are similar, means that they have similar electronegativity, hence this compound is non-polar molecule. Question number 3. Which of the following is the molecular geometry for the NH3, which has the following Lewis structure? So if we want to know the molecular geometry, first thing we have to determine the number of electron domain. Single bond, consider 1 electron domain. Double bond, also consider 1 electron domain. Triple bond, also consider 1 electron domain. Lone pair, consider 1 electron domain, lone pair electron. And single electron, also consider, or unshared electron, also consider 1 electron domain. So based on this Lewis structure, we have 4 electron domain. So after we determine the number of electron domain, second thing we have to know what is the basic geometry or electron pair geometry. So if we have 4 electron domain, the basic geometry is tetrahedral. Okay, after we will from tetrahedral, we try to imagine there is one lone pair. So the shape of the molecule will not still in tetrahedral, but they will become trigonal bipyramidal. Is trigonal pyramidal. Question number 4. Which of the following species does not show resonance structure? Okay, so this one will based on our examples in the tutorial or in the lecture. So basically there is one tips for the compound which can show resonance structure. Normally they must contain at least 2 types of bonds. For example, it can be between single and double bond. So in the compound at least have one single bond, the rest can be double bond. Or the other way, one double bond, the rest will be single bond. So for this one, carbon dioxide, when we draw the Lewis structure for the carbon dioxide, both carbon and the oxygen bonding both are double bond. So that's why carbon dioxide does not show resonance structure. Question number 5. Which of the following species has ionic bond? So basically when has ionic bond, we will think of that is between metal and non-metal. So with this idea, CCl4 and NH3 will be out. So we left another two, AlCl3 and AlF3. So for your information, there are several metals can form covalent compound, which are beryllium, boron, aluminium. These three possible to form covalent compound. However, if they want to form covalent compound, the electronegativity, the difference of the electronegativity have to be in between 0.7 up to 1.5. So as we know, fluorine is the most electronegative element. So means that the difference of the electronegativity between fluorine and aluminium will be larger than AlCl3. So in this case, AlF3 will be considered as ionic bond. Question number 6. Basically, we want to check whether the compound obey octet rules or no. When we want to check this, we always focus on the central atom. So in this case, the central atom is boron. So when we calculate the number of electrons surrounded the boron, there is only 6 electrons. So the answer is incomplete octet. So question number 7, the type of bond that involves the sharing of electrons. So the keyword here is sharing. So the answer will be covalent bond. Question number 8, which of the following has the highest boiling point? When we look at the boiling point, means that we have to determine the intermolecular force. Again, before intermolecular force, we have to determine type of compound. So when we look at the choice given here, all these are covalent compound because consist of non-metals. Carbon, hydrogen, and oxygen are non-metals. So we need the highest boiling point. So means that we have to look for the strongest intermolecular force. So the strongest intermolecular force that can be found between the covalent compound is the hydrogen bond. So when we look at here, very obvious, butanol is the compound that able to form hydrogen bond. So that's why butanol has the highest boiling point. So the rest of these, propene, ethane, and methane, these three we are considered non-polar molecule. So if they are non-polar molecule, so the intermolecular force are London forces. So in this case, the factor that will influence the boiling point is the molecular size. Therefore, if we want to arrange in order of increasing boiling point, methane will have the lowest boiling point, followed by ethane, followed by propene, and then the highest boiling point will be butanol. Okay, question number 9. Group 4, so we know that this element is D block element. So when we look at the answer, option 1 will be out. Option 4 also will be out because both option 1 and 4 are referring to P block element, and then they are period 4. So both 2 and 3 are possible. So group 4 means that they have 4 valence electrons, at where 2 will be from s orbital and then another 2 will be from d orbital. So means that the answer will be number 3. Question number 10. Which element has the highest first IE? So basically we will notice all these elements are in period 3. So we will have the idea across period IE is getting higher due to the size is getting smaller. However, in this case, there is anomalous cases. Okay, so phosphorus is element in group 15. So orbital 2s have 2 electrons, while orbital 2p has 3 electrons, which they will fill according to Hans rule. Sulfur in group 16, 2s have 2 electrons, 2p has 4 electrons. However, the 2p orbital in the phosphorus will be considered half-filled orbital, while 2p orbital in sulfur is considered partially filled orbital. Half-filled orbital has extra stability, and because of this extra stability, is going to the elements need more energy to remove the electron. More energy remove electron. So in this case, phosphorus has the highest first IE. Okay, question 11. We need to find the formal charge for the oxygen which level with 1. So means that we are going to calculate the formal charge for this oxygen. According to formula that we learned, number of valence electron minus number of lone pair electron minus number of bonds, which equal to -1. So the answer is -1, or another way like what I draw out here, 6 minus, in this circle we consist of 7 electrons, 1, 2, 3, 4, 5, 6 and 7. So I will use number of valence electrons, 6 of minus 7, so I will get -1. Okay, question 12. When going down a group, what the atomic radius is increased. For your information, there are 2 factors that will influence the atomic radius. Either is effective nuclear charge or shielding effect. And then another one, if comparing between atoms and ion, the radius can influenced by the factor of mutual repulsion between electrons. Okay, but because of this one is atomic radius, so we know going down the group, the factor of shielding effect will be discussed. At where shielding effect have the meanings that there are more shells occupied by electron. Question 13. What is the block for this element in the periodic table? So we focus on the outermost shell. The outermost shell is 4s. When there is s orbital, we will try to look at the electron configuration, left hand side and right hand side. Is there any d orbitals involved? If yes, we have to consider the d block element. So in this case, the answer is block D. So if we want to know the position, it will be considered in period 4 because n equal to 3 and n equal to 4. 4 has the larger value, so it will refer to period 4. But the group will be total up of the number of valence electron in block D and block S. So 5 plus 2 equal to 7. So this element, if they ask us about the position, will be period 4, group 7 and block D. Now we are in question 14. This question is asked us to look for the period and also the group for this element X. So again, we focus on the valence shell. From this valence shell, the n is equal to 2. So we know that this element X is in period 2. So option 2 and option 4 will be out. And then we look now, we can see there is P block. So if it is P block, we will get the idea. The group will be in between group 13 to group 18. So again, option 3 will be out. So the correct answer will be first one. How to get group 16? 4 plus 2 plus 10. So equal to 16. Question 15. What is the possible electronic configuration for Q? Okay, the first 3 successive IE increase gradually, but the fourth IE drastically. So from this statement, we will know that the fourth electron is from inner shell. So if the fourth electron is from inner shell, means that there are 3 valence electron. Okay, element Q is a third period element. So third period. So again, from the option here, 3 and 4 will be out because 3 and 4 consider 4s. Okay, Q can form an amphoteric oxide. So if you still have the idea, actually this Q is referred to aluminium. And all of us already know aluminium are amphoteric oxide, and then it is in group 13. So you can check here, you have 3 valence electron. So means that it is matching. So for this one, we will going to choose 1 as the correct answer. If you choose number 2 is considered as group 15 because 2 electron from s orbital and 3 electron from p orbital, and then we add another 10, it is equal to 15. So here we want group 13, so the answer is first one. Okay, question 16. What is the type of hybridization of sulfur in SF6? So as we know, sulfur has 6 valence electron, fluorine has 7 valence electron, multiply with 6. So the total number of valence electron is 48. So since this is an objective question, I will do a quick check. So 48 divided by 8 equal to 6. So I will going to know there is no lone pair electron, and then there is 6 terminal atom. So if there are 6 terminal atom, so we will know that there will be type of hybridization will be sp3d2. Okay, which we need 6 orbitals, 1 from S, 3 from P, and then another 2 from D orbital to get 6 orbital. So the answer is 4. Okay, question 17. The question asks us to look for valence electron. So again, we will focus on the valence shell. So this valence shell is 4. As usual, we have to look at left and right. Is there any d orbital? So for this case, there is d orbital at the left hand side. So I will total up the number of electrons in d orbital and s orbital, so the number of valence electron is 6. Question 18. Which of the following statement is correct about the size of aluminium and aluminium 3+? So like what we discussed before, if we are comparing atom and the ion, maybe it will involve the mutual repulsion, the factor of mutual repulsion. So or there is another factor that we can consider is effective nuclear charge. As we all know, cation, because they already release electron, so basically the size of cation will be smaller than the atom. Hence, option 2 and option 4 is out. So what are the factors? If we look at the first one, the remaining electrons are pulled closer to the nucleus. Second, the third option is because they have less protons. So option 3 is wrong. Okay, number of protons always remain. Okay, and as well with the neutron. In the chemical reactions, most of the time is the involving electron. So the number of electrons can be changing. So because you already lose 3 electrons, so the remaining electron will be pulled closer to the nucleus. So option 1 is the answer. Question 19. Which of the following is the most plausible Lewis structure for SO2? So most plausible means that they will have the lowest formal charge, where means that the the formal charge for each atom, if possible, is equal to 0. Okay, so we look at here, sulfur has 6 valence electrons, and so for the oxygen. So means we will going to use 6 times 3 equal to 18. 18, if I divide by the 8, I will get 16, and then there will be have 2 lone pair electron. So 2 terminal atom and lone pair electron. So if we look at the structure, all the option here 1, 2, 3, 4, the sulfur have lone pair electron. Okay, so then we have to do the calculation. So basically, just now we already do calculation in the previous question. If the oxygen with the single bond, the formal charge is -1. So this one is -1, -1, -1. Okay, so for the oxygen with double bond, 6 minus 4, unshared lone pair electron, and then number of bonds 2, so equal to 0. So this one 0, 0. This one the formal charge also 0. This one also 0. And then for sulfur, so in this case sulfur is similar with oxygen, so the formal charge also 0. So for this question, the correct answer is 1. If the oxygen has triple bond, so will be considered as 6 minus 2 minus 3, so equal to +1. So if the oxygen with triple bond, formal charge is +1. So now we try to calculate the formal charge for the sulfur. So for this sulfur is 6 minus 2 minus 5. So 6 minus 2 minus 5, you will get -1. And then for sulfur in the option 3 will be 6 minus 2 minus 3, so will be +1. For sulfur in option 4, 6 minus 2 minus 2, so will be +2. So it is very obvious. The correct answer is option 1. Okay, last questions in this video. They asked us about the bond angle for this molecule CH4. So as we all know, this compound have 4 electron domain. So the basic geometry is tetrahedral. So when it is tetrahedral, the bond angle is 109.5 degree. So the answer is option 3. 104.5 is the bond angle for water, while 107 or 107.3 is the bond angle for ammonia, and then 180 is the bond angle for compound with the linear structure. Okay, so I hope this video can help you to prepare well in your UPS 2. Thank you for watching.